Are you working on agentic systems or just starting to develop AI agents? Watch this video where I show you the easiest way to deploy your AI applications. In this video, we will create an agentic application with multiple assistants collaborating on a task. We will also deploy this application to the cloud without needing accounts with OpenAI, Anthropic, or other LLM providers. To do this, we will use AutoGene, Gradio, and OmegaCloud. Let me show you. AutoGene is an agentic framework for building AI agents. What I love about this framework is that it allows you to develop truly agentic systems with multiple agents collaborating autonomously on a task, rather than designing rigid workflows with steps, loops, gateways, and so on. Gradio is a Python framework that simplifies the development of interactive applications. Think of it as a front-end framework for Python. And OmegaCloud is a backend platform that provides infrastructure, services, workflows, and inference to run your application with zero hassle and at a maximum speed. To do this, you just enter Omega Run. That's it. So let's begin. First of all, I will create a directory for our new project. I initialize it with UV and add AutoGene, OpenAI, and Gradio for our project. OmegaCloud is a framework agnostic platform, so we don't need to install any dependencies for that. Okay, let's start. First of all, let's create a Gradio interface and launch it. For our application, we will use Gradio. We import it as GR. Here we create chat interface. We define title, chat box, text box, and we also use chat with agents function that we will implement further on. Okay, let's define chat with agents function. This function will take two arguments, message type of string and history type of list. And it will return string. This function will handle chat interaction with our agents. Inside, we need to create agents, create user proxy, create a group chat for our agents and user proxy. We also create chat manager that will be responsible for managing conversation. We start the chat, and in the end, we format the history of the chat and return to the user. Before creating agents, I want to add another file, agents.py, where I define agents and their roles. I define two agents. One agent with name assistant, and its role is to provide answers to our questions. The second agent is reviewer. Reviewer checks the answers from assistant and identifies potential errors, suggests improvements, and so on. And we also need a proxy. We call it user proxy, and this is intermediate between real person, real user, and this agentic system. And this user proxy will interact on our behalf and reply terminate when the task is done. So when reviewer thinks that everything works fine. We will need agents and proxies later on. We also need to define some LLM-specific variables. For example, model. We will use Gemini 2.5 Flash for our project. To use this model in AutoGene framework, I need to define LLM config with config list. Config list is the list of dictionaries with definition of our models we use in our agents. And we pass this config list into LLM config. And LLM config will be used in any agent, proxy, and manager we will use in AutoGene later. Okay, let's define our agents. I will create a list of assistant agents imported from AutoGene. And we will generate this list from agents defined previously. So I import from agents, import agents and proxy. Okay, and we use agent name and agent role we defined here. So this list will have two agents. Now let's create user proxy. Nearly the same way. We use user proxy agent. We use proxy name, proxy role. We use the same LLM config with the same model. We also tell AutoGene not to ask user on any input, and we block code execution. So now we create group chat. We add our user proxy and assistants in this group chat and specify round-robin method for communication. Next, we create chat manager who will be responsible for managing conversation between agents and user proxy. And here we use terminate word, like a stop word, when the task is done and we need to wrap up the conversation. And eventually, we initiate the chat. We use our group manager as the recipient of the message we provide from the user interface. Okay, and in the end, we just collect our messages from this chat. We use chat history, iterate messages in this chat history, and just combine them in the formatted string. So our application is ready, but there is one nuance here. When I define model, I commented out two parameters, API key and base URL. If you use OpenAI, Anthropic, or Gemini LLM providers, you just provide API keys and base URL here. But since we use OmegaCloud, we don't need to do that. This will be done automatically by the cloud platform. So I can either load API key or base URL from environment variables like that, or I just skip this and make OmegaCloud does its work. Okay, now let's run our application. We deploy to OmegaCloud. To do that, I use omega run command. First of all, I go to my personal account and copy this API key. By the way, this is the same key I can use both for running applications on OmegaCloud and to use it for inference. We select the type of our application. In our case, this is web service. We choose a name, for example, chat with agents. We use just application, UVSync for installing dependencies, Python main provide to run our application. We select appropriate compute size. We don't need shared storage now. We don't need environment variables because all environment variables we need will be automatically provided by OmegaCloud. And now we need to wait a couple of minutes while OmegaCloud spins up the server, installs required software, uploads our application, and runs it. Yeah, our files are being uploaded to the server. UV installed all the dependencies we needed, and we have our chat is ready. So I click the link, and here we are. We see the application, and we can ask something. What is overfitting in ML? Oops. Meanwhile, I can see the logs in my terminal. So all the conversations, all the logs we used. For example, when we print something here, it will replicate it in the console. This is the beauty of OmegaCloud. And in the end, I see all the conversation in my application. So this is our question. Then we see that assistant answered something. After that, our reviewer replied. Then user proxy checked the answer. Assistant again, reviewer again, and the user proxy replied with terminate. So the answer of the reviewer is great. So we created an application that uses AutoGene framework. Let me remind you that AutoGene enables us to create systems with multiple agents communicating with each other around a task without prior arbitrary workflow. And we deployed this agentic system on OmegaCloud by using this is the only command, omega run. This is extremely simple way to run your applications. One more important thing is that to create AI application, we don't need to provide any LLM related API keys, accounts, and so on. Everything you need, like infrastructure, services, databases, inference, and models, All this available on OmegaCloud. So you just provide the code and OmegaCloud will do the rest. So I hope you enjoyed this video, and if you did, click like, hit the bell, subscribe our channel and follow us. I also encourage you to explore our other demos where we build stateful MCP server, deploy fast API app, or run diffusion model on a GPU. Register on OmegaCloud platform, get free credits, and use it in your AI project with ease. Watch, try, enjoy, stay tuned.